this is the third lecture of recurrence realism. So and genetic function. So that as the name suggested, generating function. So we have to generate the series. First. So for the generating function, we have to series generate. So for this, they are saying that just you should evaluate the sum 1 square, 2 square, 3 square, r square. So first we have to make this series. Okay, so I will clear this. I will take one more because it is a very long question and you should clearly understand this question, and I will open one more paint here so that I will explain clearly. Okay, now this is the first. It is saying that we want to evaluate 1 square, 2 square, 3 square and r square. So we have to make the first this term. So how we can make it 1 square, 2 square? So we are going to discuss this process. As we know that one upon 1 minus z, that is 1 minus z to the power minus 1, the expansion of this series 1 plus z plus z square plus z cube dot 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 plus z to the power r dot dot dot. So differentiation by both sides with respect to z. With the help of differentiation, we will generate all the types of series. Differentiation with respect to z. So we know that the differentiation of x to the power n equal to n x to the power n minus 1. So it becomes minus 1 minus z to the power minus 2, and we have to differentiate also this term 1 minus 1, because the differentiation of 1 is constant. According to constant is 0 and minus, and the differentiation of this z is equal to 1. So the constant differentiation 0, 1 z to the power 0, 2 z to the power 1, 3 z square, r z to the power r minus 1. So this multiplication, it becomes 1 upon 1 minus z to the power 2 and 1 plus, because the z to the power 0 is 1, 2 z to the power 1, 3 z to the power 2 and r z to the power r minus 1. Okay, now just we should multiply by the z by both sides. It becomes z upon some of the students will ask why we are going to multiply by z on both sides, because to making the power equal, just like that, because here is z to the power 0, but it should be a0 z0 a1 z1, so it should be 1 z1 2 z2 like this, because in the generating function all the terms are equal. 3 z cube plus r z to the power r. So now differentiate again with respect to z. Differentiation again with respect to z, it becomes, now we will take dy dz z into 1 minus z to the power minus 2 is equal to, now the series is z1 minus 2 1 का square, 1 square 2 square 3 square, so differentiation becomes 1 square z to the power 0 plus 2 square z to the power 1, 3 square z to the power 2, 4 square z to the power 3. Next r square z to the power r minus 1. Don't know. If you will multiply that, it becomes first and second. Differentiation of first function with respect to z is 1, second term, second function as it is 1 minus z to the power minus 2 plus differentiation of second function, it becomes minus 2 and 1 minus z to the power minus 3, and also the differentiation of 1 ka 0 and minus 1. Okay, now the similar things, 1 square z0, 2 square z1, 3 square z2, 4 square z cube, r square z to the power r minus 1. After the solution we get 1 upon 1 minus z plus this minus and this minus, after the multiplication you will get 1 minus z ka cube. Okay, and there is a square, this term remain same. Just to make the denominator equal, we should multiply 1 minus z and divide by 1 minus z. It becomes the denominator equal, so we can add like this, 1 minus z to the power cube and 2 plus, oh sorry, first we should multiply, okay, no issue, 2 plus 2, it becomes 1 minus z and plus 2z, it should be 2 z 2, because the second function is this, because the differentiation of this difference second function I say this is a z, not the 2, so it becomes 3 minus 2 माइनस, अच्छा डिफ्रेंसिएशन ही रॉन्ग था, क्योंकि सेकंड टर्म तो ऐसे रहेगा z माइनस 2, तो माइनस माइनस प्लस इट बिकम्स 2z, तो यहाँ हो गया ये 2z और माइनस z प्लस 1, इट बिकम्स 1 प्लस z, टर्म is here. This is the last term. These are the sum as similar. Just we should multiply, because there is a 1 z to the power 0, 2 z to the power 1, 3 z to the power 2, 1 is less, so we should multiply by z again. So it becomes z 1 plus z upon 1 minus z का क्यूब is equal to 1 square z to the power 1, after multiplication of z 2 square z to the power 2, 3 square z to the power 3, r square z to the power r. Okay, so by both sides we should multiply 1 minus z, multiply 1 upon 1 minus z. कुछ स्टूडेंट पूछेंगे ऐसा क्यों कर रहे हैं, ये जो न्यूमेरिक फंक्शन है जो मुझे बनाना है उसको फाइंड करने के लिए हम ऐसा कर रहे हैं, ठीक है। अब आप जरा इसको समझिए कि कैसे हम इसको सॉल्व करते हैं। सो इट बिकम्स z मल्टीप्लाई बाई z प्लस z स्क्वायर अपॉन 1 माइनस z का क्यूब। Now we should take the expansion of this series, 1 minus z to the power minus 1. First I am writing like this, 1 minus z to the power minus 1, and the remaining term remains same, 1 square z to the power 1, 2 square z to the power 2, 3 square z to the power 3, r square z to the power r. Okay, now we should expand this series, 1 plus z plus z square plus z cube. Now the rest series remains same. Now we should multiply by this one to the whole series, by this z to the whole series, by this z square to the whole series, by this z cube to the whole series, by the something, okay, and by z to the power r to the whole series. Now this become I will write like this. If you will multiply to this series by 1 to this series by 1, it remains same, 1 square z की power 1, 2 square z to the power 2, 3 square z to the power 3, 4 square z to the power 4, and r square z to the power r. Now not equal to basically it should be plus. But when you will multiply this series by z, this series by z term, so it will increase the 1 power to the whole series, so it becomes z to the power 2. So we should write under the z to the power 2. So it becomes, if you will multiply z this term, so it becomes 1 square z to the power 2. It becomes 1 square z to the power 2 and 2 square z to the power 3, 3 square z to the power 4 something. Okay, r plus 1 square z to the power r plus 1. Now next, just you should multiply by the z square, so it will increase the 2 power to the whole series. It becomes z to the power 3. So 1 square z to the power 3. So 1 square z to the power 3, 2 square z to the power 4. A similar r plus 2 z to the power r plus 2. Similarly, when you will multiply next z cube to the whole series, it becomes z to the power 4 1 square. One square z to the power 4 and dash dash dash. Okay, so just you should think that if we have the z to the power 1, the term is 1 square. If we have the z to the power 2, the sum is 1 square plus 2 square. If we have the z cube, the total sum of 1 square, 2 square, 3 square. If we have the z to the power 4, the 1 square, 2 square, 3 square, 4 square. If we have the z to the power r, the sum becomes 1 square, 2 square, 3 square and r square. So the coefficient of z to the power r, the coefficient of z to the power r is known as numeric function. So is 1 square, 2 square, 3 square and r square. So it becomes the desired function. So this is called generating function. Now we have the z plus z square upon 1 minus z to the power plus 4. So we should also find the coefficient of z to the power r in this term. So now we should take one more paint. So we should find the coefficient of z to the power r in z to the power r in z plus z square or 1 minus z to the power minus 4. Okay, so we know that by the binomial theorem, if you will study, you have studied in the 12th class, the binomial theorem expansion is that 1 plus z to the power n. So the result will be this: if n become m in n is positive, if n is even number, so the term, all the term result will be positive. If n is negative, the term will be negative term. Or n is odd number, the term will be negative. So here n is here 4, so the result will be all positive. The answer is n minus 1, n minus 2, n minus r plus 1, n equal to 4. So it becomes minus 4. So minus 4 or plus 1, you should just put the value to getting the z to the power r coefficient in this term. Just you should memorize, you will get by the 12th class. N minus 1, n minus 2, just you should pull the n equal to minus 4. So minus 4 minus 1, minus 4 minus 2, minus 4 plus r minus 1. So it becomes like this. minus 4 minus 4 minus 1 minus 4 minus 2 minus 4 minus r plus 1 divided by r factorial into z to the power r. So if you will solve minus 3 minus 4 plus 1, it becomes r minus 3, because it is a even number, so all the terms should be positive. So it becomes like this: r plus 1 r plus 2 divided by 6. Okay, so I will explain here. Z plus z square. Just by the binomial theorem we know that the differentiation, the z to the power r coefficient is that 4, 5, 6 and r plus 3 and divide by r factorial like this. You should multiply by 1, 2 and 3, 1, 2 and 3, and just you should reduce this: r plus 2, r plus 1 and r. The continuous multiplication from 1 to r is r factorial. ये कट जाएगा और ये बन जाएगा z plus z square and r plus 1 r plus 2 and r plus 3 divided by 6. If you will multiply z to the power 1, it will increase z to the power 1. So you should put r equal to r minus 1, because here r, it will increase the value of z to the power 1. Now if you will multiply z to the power 2, it will increase 2 power. It will increase 2 power. So if you will increase 2 power, so you should put r equal to r minus 2, then you will get z to the power r coefficient. So these two terms we have get r plus 1 r plus 2 divided by 6, r minus 1 r plus 1 divided by 6, and after the solution taking the common and LCM, we will solve this. So the sum of the the sum of the 1 square, 2 square, 3 square, r square equal to r plus 1 to r plus 1 divided by 6. Thank you. This generative function we have already discussed. These are the reference. Thank you.